Welcome to the 7th lesson in measurement for this CSEC mathematics series. Today we will learn how to calculate the surface area of solids such as cubes, cylinders, pyramids, cones, and spheres. The first question that we have to answer is, what is surface area? Surface area is the total of all the areas of the faces or curved surfaces that make up a solid. It can be used to determine the amount of material needed to cover a surface, such as when packaging items. The first shape we'll discuss is called a prism. A prism has uniform cross-section along its length. That means if I were to cut anywhere along its length, I would be able to get this exact same base. To calculate its surface area, we look at the area of the sides and the area of the bases. The sides are called the lateral surfaces, which are the faces that connect the two bases and extend along the length. So this here is a lateral surface, this here is a lateral surface, the underneath and the back are all lateral surfaces. The lateral surface area can be found by multiplying the perimeter of the base, which is this, by the length, which is this. We then add the area of the two bases here, and we'll be able to get the total surface area. Now, as long as you have any prism that has two bases connected by these lateral surfaces, you'd be able to determine the surface area with this formula. 2 times the area of the base plus the perimeter of the base times the height of the prism. Let's try an example. We're required to calculate the surface area of a rectangular prism with a length of 10 centimeters, a width of 5 centimeters, and a height of 7 centimeters. The first thing we want to do is to draw a diagram. Next, we identify what we would use as the base. I will use this green region here as the base of this prism. That means this yellow region over here and here will be my lateral surfaces. So let's calculate the surface area. The next shape we'll look at is called a cube. A cube is a special type of prism where all faces are squares. To calculate the surface area, it's very straightforward. We simply use side squared times 6. Let's try this example. Find the surface area of a cube with an edge of length 4 centimeters. Now for this one, I don't need to draw a shape, but I'll draw a shape first. Next, we calculate the surface area. The third shape we'll look at is called a cylinder. A cylinder's surface area consists of the lateral curved area, I should say, and the area of two circular bases. Unlike a prism, a cylinder is called a solid of revolution, meaning it is formed by rotating a rectangle around one of its sides. You will encounter more about solids of revolution in additional mathematics. For now, note that we find the perimeter of the circular base using 2 pi r and multiply by the cylinder's height here to get the lateral surface area. Then we calculate the area of each circular base with the formula 2 pi r and multiply by 2 to cover both bases. And then we add these together to give the total surface area. Now, with a little bit of algebra, we can simplify this formula into 2 pi r plus the height plus the radius of your cylinder. Let's look at this example. The first thing I need to do is draw the shape. Next, let's find the surface area. The fourth shape we'll look at is called a right pyramid. And a right pyramid has its apex directly above the center of its base. And the base is a regular polygon. In the case of a square right pyramid, the base is a square, and all the triangular faces are congruent isosceles triangles. The slant height is the height of each triangular face from the base edge to the apex. The surface area of a right pyramid includes the area of the base and the sum of the areas of the triangular faces. Now, these triangular faces, when combined, are very close to a parallelogram. So what we need to do is use the area for whatever base we have, plus the area of a parallelogram, which has a height equal to this slanted height, and it has a length equal to the circumference, or the perimeter, I should say, of the base. Let's try and solve this example. Calculate the surface area of a square right pyramid with a base of 6 meters and a slanted height of 5 centimeters. That's an error. That's supposed to be 5 meters. Anyway, let's solve the problem at 5 meters. First, I'll draw a diagram and label the sides. Next, let's calculate the surface area. The fifth shape we'll look at is called a cone. Now, a cone is similar to a right pyramid in that both taper from a base to an apex. However, they differ in important ways. Now, while a right pyramid has a polygonal base and flat triangular faces, a cone has a circular base and a continuous curved lateral surface. The slant height of the cone is analogous to that of a pyramid. In other words, it serves a comparable purpose by measuring the distance from the base edge to the apex along the surface. The surface area of a cone includes the area of the circular base and the lateral surface area, which can be visualized as a sector of a larger circle when unfolded. Now, a cone and a cylinder are similar in that they are both solids of revolution. I will leave it up to you to figure out what shape is revolving and how it's revolving to produce a cone. Let's try this example for the surface area of a cone. First thing I want to do is to draw a shape. The final shape we'll look at is called a sphere. Now, the surface area of a sphere is calculated using a specific formula that reflects its symmetrical, perfectly rounded shape. Like other curved surfaces, a sphere is also a solid of revolution. And to calculate its surface area, we simply take 4 pi times the radius squared. Let's look at this example. And that's it for today's lesson. In this lesson, we learned the various formulas used to calculate the surface area of the listed shapes, and you should have noticed that all the area formulas that you were introduced to in the previous lessons came back in this lesson. When you learn algebra, you can learn to derive and simplify some of these formulas, and when you do solids of revolution in additional mathematics, you will understand how to get the rest of the formulas. Thank you for joining me in today's lesson on surface area, and in the next lesson we'll learn how to calculate the volume of solids. Feel free to leave any questions or comments below, and don't forget to join the Google Classroom for the series resources. See you in the next lesson. Bye.